Hello dear students of plus 2 medical and non-medical respected teachers. So today I am going to discuss PN junction or diode and its characteristics from chapter of semiconductors. So let us start first of all, what is PN junction or diode? So PN junction or a diode, a combination of P type and N type material. And how it is formed? We take a crystal of germanium or silicon. When one end of germanium or silicon is doped with p-type impurity and other end is doped with n-type impurity during crystal growth, then the device so formed is known as PN junction or diode. Then due to thermal agitations, a few electrons from n section get diffused into p section, thereby leaving n section at slightly positive potential. Similarly, few holes may get diffused from p section to n section, thereby leaving p section at slightly negative potential. After some time, diffusion of holes and electrons stops, and a potential difference is created across the junction, and this potential difference is known as potential barrier, and it behaves like a fictitious battery with its positive terminal to n section and negative terminal to p section. For germanium, this potential barrier is of the order of 0.3 volt, and for silicon, this potential barrier is of the order of 0.7 volt. And as a result, a small thin region is created across the junction, having thickness of the order of 10 to the minus 6 meter, of the order of micron, and this region is known as depletion layer. So this is how PN junction or diode is formed. Then circuit symbol for PN junction or diode. So this is arrow and bar. Arrow is P side, bar is N side. This is known as anode, this is known as cathode. This arrow gives the direction of flow of holes and hence direction of flow of current, because direction of conventional current is always opposite to the flow of electrons. That is, electrons and holes, they flow in opposite direction. That's why direction of holes is taken as the direction of conventional current. So this is what is PN junction and how PN junction is formed basically. Now characteristics of PN junction. There are two types of characteristics of PN junction. Number one is forward bias, number two is reverse biased. When P type is connected to the positive terminal battery and type to the negative terminal battery, and PN junction is said to be forward biased. When this PN junction is forward biased, a few electrons from N section get diffused into P section because P is connected to the positive. Similarly, few holes may get diffused from P section to N section. In other words, an electron coming from N section utilize the hole and hole is created in the N section. So it means electrons and holes, they flow in opposite direction, we can say. And the direction of holes gives the direction of conventional current, like this, clockwise. So when the graph is plotted by taking forward voltage along x-axis and the forward current along y-axis, we get the graph like this. From this graph, you see that initially forward current is nearly zero, and then it increases with the increase of forward voltage. And this point up to which the current is nearly zero is known as the potential barrier. So after crossing the potential barrier, current rises rapidly with the increase of forward voltage. And if we calculate the slope of this graph, so delta V is the change in voltage corresponding to change in current delta I. Then RD, resistance of diode, is given by 1 upon tan theta. Tan theta is slope, reciprocal slope of the curve, that is delta V upon delta I. So it means during forward bias, current increases rapidly with the increase of voltage beyond the potential barrier. When voltage crosses the potential barrier, that is which the threshold for voltage, then current increases rapidly with the increase of. So this graph is known as forward bias characteristics of PN junction diode. Similarly, reverse bias characteristics, when P type is connected to the negative terminal battery, N type to the positive terminal battery, the sorry, for PN junction is said to be reverse biased. During reverse bias, what happens? Majority carriers, that is of P section and N section, they move away from the junction. As a result, thickness of depletion layer will increase. Reverse is the case in case of forward bias. Majority carriers of P section and N section move toward the junction. Thickness of depletion layer decreases. That's why during forward bias, PN junction offers less resistance to the flow of current. But in case of reverse bias, majority carriers move away from the junction, and hence thickness of depletion layer increases, and hence it offers infinite resistance to the flow of current. There is small current due to minority carriers, that is holes of N section and electrons of P section, so which cross the region depletion layer. That's why there is small current which is of the order of 1 microampere. So during reverse bias, PN junction diode doesn't conduct practically. Okay. If you plot a graph taking reverse voltage along x-axis and reverse current along y-axis, you get a graph like this. There is a small current which is of the order of 1 microampere. It is only due to small minority carriers of P section and N section, which is negligible, is of the order of 1 microampere. But if we go on increasing the voltage, a stage comes at a particular voltage Vz, known as zener voltage, current rises abruptly, suddenly, and becomes independent of voltage. This property of the PN junction diode during reverse bias makes it to use as a voltage stabilizer, because current becomes constant. It doesn't depend upon the voltage. If you increase the voltage, current remains constant. Such a device is known as voltage stabilizer. It is a very, very important device. So during reverse bias, you can say PN junction offered infinite resistance. That's why current is negligible. It doesn't conduct, we can say. During forward bias, it offers less resistance, so current increases rapidly with the increase of voltage beyond a certain limit called potential barrier. So in case of PN junction diode, it conducts only when it is forward bias, and it doesn't conduct when it is reverse bias. So this is the principle of rectifier. So one of the application of PN junction diode is rectifier. So that I will discuss in the next video. So principle. So PN junction diode in nutshell conducts only when it is forward bias. It doesn't conduct when it is reverse biased, because during reverse bias it offers infinite resistance to the flow of current. If there is small current of the order of 1 microampere, it is only to minority carriers, not majority carriers. So this is all about PN junction and its forward bias and reverse bias characteristics. So all the best, be happy, stay tuned till next video. Good luck.